You ever see a pattern out in the world and wonder, hey, is that a real thing or is it just a coincidence? Well, today we're going to demystify the chi-square test. It's a surprisingly straightforward tool that helps you figure that out for sure.
So let's start with something we can all get our heads around. Is there actually a meaningful difference between cat people and dog people? I mean, it's a fun debate, right? But how would you prove it? How do you know that a pattern you think you see isn't just random chance?
Well, the good news is you don't have to just guess. There's a statistical tool designed specifically to cut through all that noise and tell you if what you're seeing is actually significant. And that tool, you guessed it, is the chi-square test. All it really does is check to see if there's a significant relationship between different categories. Things like gender, pet preference, or even just simple yes or no answers. Now, knowing when to use this is absolutely key. You would not use a chi-square test for things like comparing the average height of men and women. That's for other tests. No, its real superpower is working with counts inside of categories. It's perfect for asking how many men prefer dogs versus how many women. See the difference? Okay, to really make this stick, let's just walk through a simple, everyday example from start to finish. We'll stick with our theme of pets and people. So, imagine we go out and do a quick survey. We grab 100 people and ask them just two things, their gender and whether they're a cat person or a dog person. The big question we're trying to answer is, are these two things related at all? And the results are in. So, out of our 100 people, we found that 20 men said they preferred cats, while 30 preferred dogs. For women, it was almost the reverse. 35 said they were cat people, and only 15 preferred dogs. Now, just looking at this, it kind of feels like there's a pattern, doesn't it? But here's that million-dollar question again. Is that pattern real, or could we have gotten these exact numbers just by a random fluke? This is the very problem the chi-square test was born to solve. So how in the world does it figure this out? Well, the logic behind it is actually surprisingly simple. It all comes down to comparing what we actually saw with what we should have seen if there was no pattern at all. The whole thing really just boils down to a head-to-head showdown between two different sets of numbers. Think of it as a battle between reality and pure chance. So on one side, you've got what we actually saw, our observed data from those 100 people we talked to. And on the other side, the test calculates what those numbers would probably look like if there were absolutely zero connection between gender and pet preference. We call that the expected count. And here it is, the key idea. The test just measures how big the gap is between those two worlds, the real world and the random chance world. A small difference, could be a fluke. But a huge difference, well, that suggests that something more than just random chance is going on here. Okay, great. So the test measures a difference, but how do we get a clear yes or no answer from that? This is where probably the most famous or infamous number in statistics comes into play, the p-value. So after it does all its math, the chi-square test spits out one single crucial number, the p-value. And what that number tells you is the probability of seeing a gap as big as the one you found if everything was just random. So think about it. If the gap between your data and the no relationship world is huge, it's pretty unlikely to happen by accident, right? So it gets a tiny p-value. And to figure out what that p-value means, we compare it against a standard cutoff. In most scientific fields, that magic number, that line in the sand, is 0.05. And the rule for making the call is incredibly simple. You just look at that p-value. If it's less than 0.05, you can be pretty confident that the relationship is statistically significant, it's likely real. But if that p-value is more than 0.05, we have to say, nope, the pattern we saw was probably just a fluke. All right, let's zoom out for a second. Knowing how to use one tool is great, but a real pro knows which tool to grab for which job. Let's see where chi-square fits inside your growing statistical toolkit. Seriously, by getting this, you've just unlocked a whole new way to look at the world. You've got a powerful new tool that can help you find relationships in data that you might have missed before. So here's a quick guide to see how it fits in with some other common tests. If you're comparing the numerical averages of just two groups, you'll want a t-test. If it's 3 or more groups, you'd use something called ANOVA. But anytime you are working with categories and counts, like we just did, chi-square is your go-to tool. So let's wrap this all up. Here's your chi-square cheat sheet. You use it for categories and counts. The whole game is comparing what you observed versus what you'd expect if it was all random. And that magic number, a p-value under 0.05, is your green light that you've probably found a real relationship. And that's really the chi-square test in a nutshell. It's such a great way to look at the world and start to uncover some of the hidden relationships in the data that's all around us. Which really just leaves one last question for you. Now that you know how to look for them, what hidden relationships are you going to uncover?